Okay, let's begin. So exponents or indices, depends, I guess, whether you're, which side of the Atlantic you're on. But anyway, exponents or indices come up a decent amount on the test. You'll have about 4 or 5 problems dealing with exponents. And usually you get about 2 on section 3 where you won't have a calculator. So you'll be in a position where knowing the rules and how to work with exponents will be very helpful in figuring out the answer. So when it comes to exponents, the test expects you to know about 4 things and these 4 things really well. And don't worry, we'll cover exactly what the 4 things are and we'll look at exactly how they present themselves on the test. But the things you want to be able to do is you want to know how to divide and multiply exponents. You want to know how to distribute powers across exponents. You need to know how to work with negative exponents. And last but not least, you need to be able to convert back and forth between fractional and radical form for exponents. And again, what we'll do is we'll spend the first half of this video looking at the rules, making sense of them. If you feel like you're already pretty good with the rules, you can try to fast forward to the second half of the video where we'll go over maybe 4 problems from past exams. But anyway, let's just quickly hit some of these rules now. So first things first, if you have the same base but different indices and you're multiplying by one another, you add the tops. And this makes sense conceptually because x to the second is x times x. So this is x times x, and then it's times x times x times x times x. So if you think about it, it's x times itself 6 times, or x to the 6th. Dividing exponents kind of follows similar logic. So if you have the same base but different tops, and I'll make this a little bigger, if you think about it, you'd have 7 y's. 1, 2, 3, 4, 5, 6, 7. Y times itself 7 times on the top, 3 on the bottom. Well, you'll be able to cancel out 3 of those, so you'll be left with y to the 4th right there. Okay, so again, we can do this if we have different indices or powers on the top but the same base. Another thing that you're going to want to be aware of is if you take a power to another power. So if you take a power to another power, then you multiply the tops. So c to the second to the third, instead of adding, you're multiplying the tops and you get c to the 6th. Okay, so this next rule, when you have the same power but different bases, is one that people get tripped up a lot on the test. And I'll show you exactly how that happens. But first, let's just see the rule. So if you think about this, 2 to the 3rd is, well, anyway, both of these are being taken to the 3rd. Because they're being multiplied by one another, you can take out the 3rd. If you think about it, it works because if I wanted to, I could distribute the 3 back to both because it's multiplication. I'm allowed to distribute the 3 across multiplication. Why does that work? Well, let's look at it. We have 2 times 5, 2 times 5, and 2 times 5. Right? That's essentially what this is. So because we have 2 times 5 3 times, you can think of that 2 ways. You can either think of it as, oh, it's 10 to the 3rd, right? 10 times itself 3 times, or you can think of it as 2 to the 3rd times 5 to the 3rd. Either way, we get the same thing. We get 1,000 there. So anyway, the one thing to be aware of, and the test will really try to do this to you, so the one thing to be very cautious of is the reason why we're allowed to distribute across the top. We'll take this one, for instance. The reason why we're allowed to distribute is because if you think about it, it's x times y, x times y, x times y, right? That's literally what this is saying. So that's really x to the 3rd, y to the 3rd. This is not the same as x plus y to the 3rd. If you had x plus y to the 3rd, you cannot distribute across addition or subtraction. You can never do that. And you'll see that on the test, and they'll have bogus answers that assume that you've made that mistake. So you have to be really careful of that. If you really think about this, this is x plus y times x plus y times x plus y. And if you were to do that out, to FOIL and do it out, you're going to get something much different than x to the third, y to the third. All right. Anyway, so this next type of problem, or this rule, I call it the giant killer. It comes up maybe once every 3 tests. I get students who are, some of my stronger students are scoring in the 700s, and they come back and they end up missing a problem like this. And I'm like, oh man, that was so preventable. So I always try to make a point of really going over this. So the idea is this. If the radical is already in place, if you're taking the square root and the radical is already in place, the problem only wants the positive answer. So this is not y can equal 5 or -5. I know -5 times -5 would get you 25, but if the radical's there, then it's saying just the positive answer, okay? That's different than if you were to apply the square root yourself. Then you could have positive or negative, but if the radical's already there, just the positive. I'll show you exactly how this could play out. So I've made up this problem in red right here, and I've given 3 answers for the domain. I've given 4, -5, and this just means domain, 4 and -5 both being answers. So if you go strictly by algebra, you go 20 minus x, if you square both sides, equals x squared. Then you end up with 0 equals x squared plus x minus 20. So you factor this and you get x plus 5, x minus 4. So most people will confidently say, oh, the answer's C. A and B, that's foolish because that only has one of the 2 answers. Actually, the answer is not C. You would lose the point on this problem. Think about it this way. And when they ask for the domain, normally I say don't even bother with algebra. Just plug in the numbers and see what happens. But if you think about it this way, if we were to plug in 4, we would have root 20 minus 4, which is 16, and the square root of 16 is indeed 4, which is what we plugged in for x. So if we plug in 4 for x, everything works. Watch what happens if we plug in, and I'll do this in a different color, I'll do it in black. Watch what happens if we plug in the -5. We have 20 minus -5 equals -5. Well, immediately we know we get the square root of 25 equals -5. That can't be. If the radical is already there, it does not want a negative solution, right? It only wants a positive one. So that's the type of problem to really look out for on the test. And we'll go over one of those when we hit the test problems below in a moment. So yes, just something, one of the pitfalls to be aware of. Okay, negative exponents. I find negative exponents fascinating, and I'll show you why. There's an easy way to remember how negative exponents work, and also why anything to the 0 is 1, and I'll explain that in a second. But really, there's no such thing as a negative exponent. What it means is that your base is in the wrong place. Say it again with me. Your base is in the wrong place. All right. So anyway, what do I mean by that? 4 to the -2, you just drop the base to the denominator. If the base is in the denominator, in this case we have a to the -5, you just bring the base to the top. So a negative exponent is not negative, your base is in the wrong place. You just need to move the exponent. Why is that? Well, let's look. If I have 5 to the third, that's equal to 5 times 5 times 5, okay, which is 125. If I have 5 to the second, that's going to be 5 times 5, 25. 5 to the first is 5. I'll just skip the middle. 5 to the 0 is going to be 1. Anything to the 0 is 1. Okay. I'll do it down here. 5 to the -1, your base is in the wrong place. 1 to the 5 to the first power, or 1/5. Last one right here. 5 to the -2 is going to be 1 over 5 squared, which is 1/25. All right, if you look all the way at this right-hand column, and I'll kind of highlight it right here. If you look at this, what you notice is that each time we go down an indice or exponent, we're multiplying by 1 less 5. Essentially, we're dividing by our base, which is 5. So we go down from 125 to 25. Anyway, that's a way to conceptualize why 5 to the 0 is 1, and y to the negative power, we just continue dividing by the base, in this case 5, and we get 1/5. Another way to think about it that's kind of cool, I think, is if you were to have x to the third divided by x to the third, we all agree that that equals 1. Well, if you think about it, this can be written as x to the 3 minus 3, and that's the same as x to the 0. So anything to the 0 power is 1. And that's why anything to a negative exponent, the base is in the wrong place. All right, let's continue on with some more rules. So we now know negative exponents. We're going to talk in a moment about fractional exponents and what to do with those. But before we do that, let's just look at these two common pitfalls. So first things first, you can't add the tops if the bases are the same, but it's addition. It has to be multiplication. So this is not correct. We can't add the tops here. If you're curious why that is, plug in a number for a, maybe make a equal 2. A to the third is 8. A squared is 4. Well, guess what? 2 to the fifth does not equal 12. 2 to the fifth is much higher than 12. 2 to the fifth is 32. So these do not equal one another. A way to think about this one is, again, if I have 9 times 4, then I can split this. I can split this into root 9 times root 4, right? I'm allowed to do it if it's multiplication. I can't split it if it's subtraction. And again, if you're curious why that doesn't work, try it out with the numbers. Anyway, also, I hinted at this earlier, but you cannot distribute, I repeat, you cannot distribute an exponent across addition or subtraction, right? This is not this, really, it's this, because it's the same thing times itself. Okay. So this is a concept that is, we will cover fractional exponents and roots in just a second, but I want to go over this example problem, because this concept is really at the heart of the test. They love this idea, and you'll see it on a harder problem. We want to figure out what k is, but we can't compare the tops until the bases are the same. So we're going to say 2k plus 1 equals, and we'll call 8 2 to the third. Now that we have, and we'll put that in brackets, now that we have the same base, now we know that 2k plus 1 equals 2 to the 12th. So now that the bases are the same, we know the tops must be equal. So k plus 1 is going to equal 12. K is going to equal 11. So again, if they ask for a variable in the indice or in the exponent spot, you need to make the bases the same so that you can figure out what the variable is. Okay. So this is a big concept on the test. They want you to be able to toggle back and forth with ease between fractional exponents and exponents in radical form. Really simple. The top part of the fraction is your power or your indice. The bottom is your root. So 7 to the 3 over 4 is really 7 to the third root 4. Looks just like that, just as we have it down here. Okay. Looking at this one, x, and feel free to kind of pause and mess around if you want to, but x to negative 3 over 2, we drop it to the bottom because it's a negative, right? Base in the wrong place. And we have x to the 3 over 2. Interestingly enough, whenever your numerator is greater than your denominator, it is not simplified, okay? And I'll show you why that is. So I'll show you two ways. One is, if you think about this, we have x to the 3 root 2. Well, all you need is a match for it to be able to come out. We have 3 x's, right? To get a perfect square, we just need 2 x's because it's a square root. So this really becomes 1 over x root x. Okay. And another way to think about that, actually, and I'll show you real quickly here, is when we had it in this form, if you think about it, this is really, in the base, we really have x to the 2 over 2 times x to the 1 over 2. And that's really x root x. Again, just another way to recognize what that is. Okay. So anyway, let's with no further ado, let's just go to some practice problems from the test. And you can see exactly how we can put these skills towards problems. So 8 you should be able to do pretty quickly. Feel free to pause the video and give it a quick shot. It's the concept we were just doing. So it wants to know, it tells us that this is equivalent to x to the a. We all have fractions as answers, so let's rewrite this in the fractional form. So x to the 3/5, right, power over root is equal to x to the a. So in this case, a must be 3/5. Okay. 9 is the one that applies to that giant killer rule. Remember, if the root is already there, then we only want the positive answer. What does that mean? So it wants to know which of the following values of x is not a solution. Immediately, this one is going to be a. It's going to be -4, because the square root of anything cannot equal a negative number. So without even doing any math, it can't be -4. You can try all the other numbers out and they'll work. -4, when the radical is already there, we do not take the negative form of the answer. Okay. Let's look at 12. 12 wants us to step our game up a little bit with toggling between radicals and fraction form. So these are all in fraction form. So let's do it. So we'll split this up into √3 f 6 to the a times √3 of k squared. Okay, so if we write this as a fraction, this is going to be f to the 6a over 3, so really f to the 2a. This k1 is a fraction, is going to be k power over root, so power is 2, root is 3. So if we're looking for our match, I think we found it in D right here. There we go. Okay. This problem 17 is a really clever problem. So everything's in fraction form, but there's one other thing we're going to need to know how to do. So let's put everything in fraction form. So we have b to the first power over 3 times b. I'm going to call this 3 over 3. I'll keep it as just b for now. You'll see why. And then this last one is going to be b power 2 √5. So if we want to, they all have the same base, they have different tops. We want to add the tops, but as you remember with fractions, and this is at the heart of the exponent problems on the test, they love this idea. You can't add the fractions on the tops unless they have the same denominator. So we're going to call this b to the 5 over 15 times, sorry, that is a 15 there, times b to the 15 over 15 times b to the 6 over 15. Well, first things first, one of these is 15 over 15, so really the answer has to be D, just by looking at the potential answer choices. But if we add the tops, we end up with b 26 when we add 5, 15, and 6 together over 15. So that one's D. Okay. I think we'll do one more. Let me see if I have one more in store for us. Actually, no, that was the last one. There are only 25 problems on this packet, so I have to save some for you. I don't want to steal your thunder. Anyway, I hope this video is helpful. Good luck with your indices, aka exponents work. And as always, come back for more videos.